Hey guys, well, welcome back to another video in our Android starter course in the book tracking application that we're making here. So we're going through various Jetpack libraries and how we can combine their functionality to create an actual useful application. Now, if you're just joining us, you can get the starting code for this video off of GitHub, and the link for that is down in the description below. Or if you've been following along, just simply use the code that you ended with from the previous video. So far, we've been able to do actually quite a bit with our book tracking app, and we've explored a good amount along the way, but what happens if, like, my phone loses signal or something? So here, I've got this application that's pulling from the online database, but if I turn off my internet, and then if I relaunch that application, because we're only pulling that data from our online database, all of a sudden, if I relaunch that application, I'm not going to get any response at all, just a blank white screen and an error. Well, we want a way to take that information, that data that we're getting from our online database, and go ahead and cache it into a local database, so that if I lose signal or if I lose my data, my phone goes offline, then I'm still able to use the app and function. So to fix this issue, we're going to go ahead and cache all of our data in a local database using something called Jetpack Room. Now, Jetpack Room is a database library that's provided with the rest of the Android Jetpack libraries. And after our database is implemented, we're then going to discuss a concept here called the single source of truth, which is something that we can use to make our database the only point for where anything in our application is pulling data, so that we don't get mixed messages and unexpected errors by pulling some data from online and some data from the local state and some data from the local cache. So we really want all of our data to be coming from one single point. So after we implement our room database, we're going to go ahead and do that. Now, we don't want our application to stop working whenever the internet goes down. So there's a couple of different ways that we could do this, right? We could use shared preferences, which is used to store lightweight data like user selections, and it stores it just in a key value pair, and then you can fetch it from that whenever you need to. We could store it in the actual device storage itself, which means we could make files such as pictures or videos or text files or anything like that, and save it onto our actual device, and then whenever we need it, just access it from there. But that is also not what we want to do. Instead, we're going to do something called a SQLite database. And this is essentially the Room database library is an implementation wrapper for the SQLite database. And it's used for storing app data inside of a private database inside the app itself. So SQLite is an open source database that stores the data in basically private text files within the app storage. And Jetpack Room provides us with a pretty decent implementation of SQLite database for Android. So here we'll be looking at this third option, using the database. And we're going to see how we can use that database to store the code, or not store the code, to store our information. So this information, what we're storing in our book right here, we're going to store that in the database as well, so that we're not just fetching that remotely. And of course, this data here is going to be the perfect candidate for storing within our database, because as you can see, this is a data class. So a data class in Kotlin is a class that only contains data fields, right? So there's no brackets down here with functions, fun, get, whatever. There's no functions at all in the data class. This is only data, so we can store that very easily in our database. Basically, to get data into your SQLite database, we would have to use a SQLite API, and to implement that, you have to do some very difficult and low-level things in your code, and they have no compile time verification, and there's a ton of tedious boilerplate code that you would have to add, and we just would have to write it and then test it, and that would be a huge pain. But luckily for us, because of all of these difficulties, Google is going to provide us with something called the Jetpack Room library as a wrapper to simplify basically our interactions with the SQLite database. So basically, what we're going to have to implement is an entity, and that's going to define what the rows in our database tables are going to look like. So our entity is going to be pretty much this data class right here. We're going to be storing all of that inside of our database. After that, you have to create a data access object, also called a DAO. And this is essentially an interface that's going to allow us to do some database operations from our code, such as get and insert and delete and update. And then finally, you have to create a database class in your code. So we'll, for now, go ahead and put that just right in here in our top level project line, project directory. And this is going to contain the actual database, and it'll expose it to the code, and it's going to have a reference to that DAO object. So then we can run any functions that we need from our code. So storing our data inside of a local database within our app is a good idea, because after we run the app, and once we have everything, once we've already made that network call, then we'll still be able to fetch our data from the database, even if there's no network connection available at all. So we can essentially use our app online, which is exactly what we want to do. So let's not waste any more time here. Let's go ahead and start building our database. The first thing we need to do is update our dependencies. Go into your build.gradle at the module level. Go down to the bottom. And in here, I'm going to add a section for room. And basically, we need implementation Android X dot room, and this top one here, we'll need that room KTX 2.5.1, and then we're going to need another one, implementation Android. You're going to need this room runtime 2.5.1 as well, and then finally we're going to need capped Android X, this top one. Is it the top one? No, we're going to need the compiler, this one, room compiler 2.5.1. And basically, this capped here stands for Kotlin Annotation Processing Tool. And we have to add that as a plugin in our project. So this is your dependency section in your build.gradle, but you need to go on up now to your plugin section at the top, and we're just going to add the Kotlin capped plugin here as well. So ID Kotlin capped, and once we have all of these changes made, let's go ahead and make sure to hit sync now on our project. And so, like I said, this Kotlin capped, that's your Kotlin annotation processing tool. That is essentially going to hide a lot of the complexity of the SQLite database from us, because it's going to allow room to generate most of the boilerplate code that we need at compile time. It's going to do that automatically, so we don't have to worry about that. So after that syncs up, let's go on over to our book object. So within our main package up here, we've got this book object, and this, like I said, is going to be our database entity. So we're going to actually need to annotate that with entity, and that of course is going to give you this import AndroidX room.entity, which is fine, we want that. And then in here, we need to specify the table name in our database, and our table name, in this case, is going to be called books. Okay, so now that we've annotated our database entity, we need to define all of the columns within that entity that we care about using our column info annotation. So to do that, we're going to come down in here, and you just say at column info, and then within here, we're going to have to say name equals, and then whatever you want your name for your column to be. I'm just going to name them the same as we have on our serialized name. So do that for all of these. Column info name equals our title. Column info name equals, you got to spell it right, name equals our author. Column info name equals our genre. Column info name equals our series. And then finally, column info name equals are finished. Okay, so that's basically it. We've got our entire entity here. We're actually going to have a problem with this finished field in the future. So we're going to come back and make some more changes to that. But we'll come back to that and look at again when we get into the single source of truth and all of that. But now that we've created our entity, we need to go ahead and create a data access object. So again, in your project window, right click on your package, your root level package, new Kotlin class or file. And then this one, I'm going to name it books DAO, D-A-O. And in here, we're actually going to want, I did that wrong. So actually you want this to be an interface. So interface books DAO, not class. And then within here, we're going to annotate that interface at DAO. And basically, Room is going to take care of all of the unnecessary actions and implementations of this interface. So we don't need to actually define all of the, or we don't need to implement all of the functions. We just need to give the top level function definitions in here. So I'm going to go ahead and do that. So we're interfacing with the SQLite database, which is of course an SQL database, a lightweight SQL database. So our queries are going to be written using SQL. So in here, we're going to add an @query annotation. And then inside there, select asterisk, which is a wildcard. So that means everything from books. And again, here books is, if you look at your book, that's your table name. So we're selecting everything from books. So basically what this query does is it returns everything. So that's going to need to be a suspending function, and it's suspending again because we're going to be running that from a coroutine because we're doing a database operation, and that's not something you want to do in your main thread because you'll freeze up your program. And this is going to be, if we're selecting everything, we're going to call the function getAll, and that will be returning a list of type book. And then after that one, I'm going to add one more function just for inserting a item into the database, just one at a time. So insert, and we're going to say, let's go ahead and import that. Import, and then on conflict, we're going to set that equal to on conflict strategy dot replace. And basically what this means is if I'm performing an insert operation, if I have a conflict between an ID that I have already in the table and then one that I'm trying to write into the table, what should I do? And you've got a couple different options here. You can replace the one, you can abort your insert operation, you can ignore it, or you can do none down there. But basically, we're going to do this top one. So replace. And then under that, again, because this is a database operation, this is going to be a suspending function, add all books. And because we're adding all and not just a single book here, I'm going to pass this a list of books rather than a single book. And that's basically all we need for our DAO. And Room will now go ahead and implement this entire interface along with these functions. So we can move on from that. So now that we're done with our DAO, we need to actually make a database. So come on over to Book Tracker, right click, do New, Kotlin class or file. And this one we're going to call BooksDB, which is a books database. And in here, I'm going to go ahead and select File instead of Class, hit Enter. And once we have our new file, we need to do @database, which is just annotation that comes with Room. And then inside the parentheses here, we need to specify what our database is going to look like. So entities. And here we're going to have just one, which is going to be book class. So that's, of course, this book class that we defined as an entity right here with the table name of books. And then after entities, we need a version. And because we've never used this database before, I'm just going to say version 1. And then we need an export schema, which I'm going to set to false. And then down here, I'm going to make an abstract class. So abstract class books DB. And this is going to inherit from room database. And notice that this is just an abstract class, right? So room is going to, again, create the actual implementation of this class for us. So we annotate it with database. We provide our entities, which is our book class, and then we pass it a version. And this number here, so if I have this schema, and then say I take one of these column infos away, say we don't want to track the genre column anymore. If I were to delete that and then come back to my database, and if I didn't update my database schema, well, then this app would fail to run on any device that already has this database installed. So basically, you would have to change your schema number and then change your export schema to false and create a migration strategy for a new database. But don't worry about that for this video. That's way more complicated than we need to know. Just know that if we ever change our database schema, we either need to uninstall our app and we can leave it at 1 and try again, or we need to just change this 1 to a number 2. And then, yeah, basically, again, export schema, for now we're setting to false. And basically, this is something Room gives us, is that Room can export the schema of our database, but again, it's too complicated for this video, so we're just going to skip that. And then within our books database, if you remember earlier, I said our database class needs to have a reference to our DAO. So let's go ahead and give it that as well. So abstract val DAO equals books DAO. So that's all we need there. Again, this is abstract. Room is going to be the one to actually implement that. But we will need to build our database and then get a reference to our books DAO instance that Room creates when it does implement that for us. So to do that, within here, I'm going to go ahead and add a companion object. So whoops, not that one. Companion object. And within this companion object, we're going to put a build database function. So private fun build database, which is going to take context of type context. And then let's go ahead and import that. So now within here, I'm going to say books db equals room dot database builder. And then within this database builder, we're going to give it context dot application context books books db class dot java, which is just our books database class, obviously. And then finally, we need to give this database a name. So I'm going to call it books database. Nothing terribly creative there. After this, we need to do dot fallback to destructive migration, and then dot build, which will actually build our database. So what's going on here, this build database function is just going to be a room database builder. And basically this fallback to destructive migration, what that's for is anytime we update our schema, meaning we change version 1 to 2 or 3 or 4 or whatever, anytime we change our schema, we need to have a migration strategy to get to our old data to the new data. And essentially this, instead of migrating it all, this fallback to destructive migration is just going to delete the table and recreate it based on the new data that is retrieved from our app. So for what we're doing, this is much simpler and more just easy and quick, but if you have a large scale app, that might not be the strategy that you want, obviously. Okay, so now also within our companion object, after this build database function, we're also going to need a reference to our, we still need a reference to our DAO. So in the companion object, and just above this build database function, I'm going to add up here private var, um, we're just going to call this instance, and this is going to be of type books DAO, but we're going to make that nullable. And right now we're going to set it equal to null. And then after that, I'm going to add another function in here, and we're going to say fun get DAO instance, and that is going to take context of type context, and this is going to return a books DAO. And then within this function in here, so that needs to be books DAO, not book DAO. So within this function, we're going to say synchronized this, and then within there, basically, we're going to have a variable instance, and I'm going to set that equal to my all capital instance. And then down here, we're going to check if that instance is null. If instance equals null, then we are going to say instance equals build database, and we're going to pass that our context and then give it a .dao. So this instance equals build database, which is our build database function down here. That is our room database builder with the .build at the end, and then we're passing it a context, and then finally that .dao. So this instance is now going to be a reference to our .dao. So we're going to set our previous instance, the null one, equal to our new instance that we just got. And then after that, we're going to return instance. And basically, yeah, this instance is now going to be the reference to our DAO. We do need to add one more thing up here, actually. Let's say at volatile. And basically, this volatile just means that our instance is available to other threads immediately. Don't worry too much about that. We don't want to get too deep into the weeds of multi-threading here, but that's what that volatile is for. And then finally, we created this get DAO instance that passes this DAO instance from the database that we built back to our instance variable. So now within our database class, our abstract class BooksDB, this DAO actually has a reference to our, we have a reference to our DAO that we can use. So we still have one problem here. Our getDAO instance function down here is expecting a context object. But since we want to access our database from our view model and not from an activity or fragment, we don't have any context objects. So basically what we need to do is we need to expose the application context by creating a new book application class that exposes it. So come on over to your book tracker, right click on that, your project, and hit new Kotlin class or file. And I'm going to call this my book application and hit enter on that. So now within my book application file, all I'm going to do is I'm going to make this inherit from application, import that, and then within here we're going to say init, and we're going to say app equals this, and then I'm going to give this a companion object down here. So companion object, and then within my companion object, I'm going to say private late init var app is going to be of type books application. So that is, or rather book application, which is our class up here, book application. And then after that, we're going to say fun get app context. And then this is going to be our context equals app dot application context. So basically all we're doing with this function is we create this late init variable app, which is of type book application. which inherits from application, and then we have this function, which is going to return a context from our, essentially from our app, which is this. So we're exposing this context, or more specifically, our application context, to whatever we call this from. So what we need to do now to make this work is we need to go up into our Android manifest file, and then within this application block, I'm just going to go ahead and add it right here. We say Android name equals dot book application, and now we should be able to use that context within our view model. So let's go on over to our book tracker view model. And in here, I'm just going to add a reference to our DAO now. So we could say private var books DAO equals books db dot get DAO instance. And then the context that we're going to pass to this is just going to be book application dot get app context. So that is going to return our context from our application that we just made there. And then this get DAO instance is going to return our DAO from essentially right here. It's going to return this instance, which is pointing to our books DAO. So now that we have that all set up, we're ready to start working on the logic on the view model itself. In here, go ahead and go down to get remote books, this function right here, and we're going to change a few things. First of all, we're going to take this API call and we're going to store the result in a variable. So val books equals api.getBooks, and then I'm going to say books DAO dot add all, and then I'm going to add all of my books, which is the list I just pulled down from that API, and then we're going to say return with context books. So let's go ahead and run that program now and see how it looks. I'll turn my internet back on here really first, because we'll obviously need that. Whoops, and of course we have an error here. An entity must have at least one field annotated with primary key. Okay, go back to your book class. This a primary key is essentially, well, it's exactly what it says. It's the primary key. So here, our primary key, we're going to use our ID, and we're just going to say at primary key. And now run that again. You can see here, this looks the same as before. Everything looks fine. But if I go ahead and turn my internet off again, so now supposedly I have a cache, but let's restart that app, run it again, and you'll see it looks the same as before. We get nothing. And the reason for that is here in my books DAO, I'm adding all of my books that I get from the network call, this api.getBooks. I'm adding them all into my cache, but I'm never actually reading them from my cache. So let's go ahead and fix that. Let's start by changing this name. We're going to change it from get remote books just to get all books, because this is either going to be pulling from our network or from our cache. So get remote books is not an accurate representation of that anymore. So to refactor that, let's right click on that, go to refactor, rename, and then I'm simply going to change that to get all books. And when I change it there, you could see it changes it up above as well. And then with our name change, we of course want to make sure that this function is actually going to match that name change now. So basically what we need to do is here, we're pulling from our API and then writing it to our cache. So if this API fails, this API call, if that fails, meaning we don't get the data we want from the network, we want to pull it, instead of from there, we want to pull it from our database. So then we can use our DAO to do that. So to do that, I'm just going to wrap this whole thing in a try catch block. So take all of that code, stick it inside the try, and then for the catch, we're going to say e exception, and then inside that block, we're going to do when e And then inside the when is unknown host exception, is connect exception, is HTTP exception. And then in the event of any of those, what we're going to do is we're going to come down here and we're going to say return with contexts books DAO.get all, and then else we're just going to throw our error or throw our exception. So let's fix the spacing on that a little bit there. Yeah, so basically now you have, it's going to pull from your API and update your cache, or if it can't pull from your API, if it can't pull from the network, it's going to catch the exception and it's going to return books.dao.getAll. Everything should be cached. I'm going to turn my internet off again, run it again. And now, even though the internet is off, you still see everything here because we're reading in from our cache instead of from the internet. So even though we're going to get this exception here, because it's one of these HTTP or unknown host or connection exceptions, it's going to run the books.dao.getAll and still return everything I need for the app from the cache. Let's turn our internet back on here. So flip those both on, done. And then back in our application, let's mark a couple of these. So I'll just do A Tale of Two Cities, War and Peace. And once we have those marked, let's turn our internet off. Now that our internet's off, let's restart that app. And you can see I just marked A Tale of Two Cities and War and Peace, but both of them are showing unfinished now. So the reason for that is whenever I mark something here, I'm not actually updating my cache. The only place I'm updating my cache right now is when I'm reading the data in from the network. So basically, I need to update my cache here as well. But the problem is right now in our DAO, we only have a function for add all and get all. So if I'm making just one partial change on one object, I don't want to have my whole list saved in memory and then write it entirely back into the network. This is just something that would be, it's going to slow our application, and that's kind of a bad practice. So what we're going to do is give us the ability to make a partial update here. So click on your top level class, in this case book tracker, new, go to Kotlin class or file, and here I'm just going to call this partial book finished. And then in here, I'm going to mark this as an entity. Just like we marked our book class as an entity, I'm going to mark partial book finished as an entity. And then in here, at column info, and here name equals RID. And then after that, we are going to have val ID int, and then at column info name equals are finished. Basically, because, well, let me finish this, val finished boolean, and we're going to set that equal to false by default. So basically what we have now here, we have a partial book that has only the ID and then the finished field. And that is actually going to be all that we need here. Once we get in here, I'm going to add some parentheses for my parameter, and then in there I'm going to say column info and name equals r underscore ID, and then val ID type int, and then at column info name equals r underscore finished, and then val finished, finished boolean equals false. And then this entire class, I'm going to mark as an entity class because we're going to be writing that into our database. And there we go. That's all that we're going to need for our partial book finish class. And now we have something that we can use to make a partial update. And if you note here, I've got val finished, and in our book class it says var finished. So what I'm going to do is I'm going to change this in book as well to a val. And that way we have the same across the board in both of these. And the reason that we do that is because we really should be promoting something called immutability, meaning we can't change things, so that we can ensure that across all recomposition events in Jetpack Compose, basically we can ensure that all recomposition effects are going to happen when they should. And if this is a var, and then we run the risk of Compose missing a needed recomposition during runtime potentially. So it's just going to be safer to have that as a val. But now, of course, if you come into our book tracker view model, you'll notice we have an error down here, and it says books map id.finished equals true. So basically, because we changed this, because we changed this to a val, we can't change it just like this anymore. So we can fix that. We can say to mutable map, and then down here, instead of this book maps ID, we're going to say val book equals book maps ID, and then instead of this dot finished equals true, what we're going to do is we're going to do our Elvis operator, and then return for each. And then after that, right here, I'm just going to say books map ID equals book.copy finished equals true. So here, this book.copy, this .copy function for the state is going to copy, it's going to save book back into this books map, and the only thing that's going to modify in that is our finished field by setting it equal to true. So now, basically we've changed our list to a map with an int using this toMutable map, and then finally we got it to a book object, and then here we use a .copy and change our finish to true instead of just doing .finish to true like we did before. But now we also need a partial update function in our DAO. So let's come on over to our DAO and let's build a partial update function for that. So we're going to say @update, and this is going to be an entity. It's going to be a book class because the book is obviously what we're updating here. And then suspend function update. This is going to take in a partial book. Yeah, I'm just going to call this partial book : partial book finished. And now our DAO, of course, this is just our interface, but Room is going to build the actual implementation of that. So now our DAO knows how to do a partial update. So we can use the implementation of this function in our toggle finished function back in our view model. So come back over to your book tracker view model. I'm going to add another function in here, and we're going to call this toggle finished DB. So down here, it's going to be private because we're only going to call it within this class. And I'm going to say private suspend function toggle finished DB, and that's going to take in an ID of type int and then an old value, which is going to be a Boolean for our finished field. And then I'm going to set this equal to with context and then dispatchers.io, because this is again a database function. So we're going to want to be doing all of that on a coroutine. And because it's a database function, we want to do that specifically within dispatchers.io. I'm going to say books.dao.update, And then within this update, I'm going to say a partial book finished object. My ID is going to be equal to ID, and my finished is going to be equal to the inverse of my old value. So once I have this function here, basically we're creating a partial book finished object, which is of type ID, or which is, it's got an ID and then a finished value, which is the opposite of the old value that we pass in. And then we update, we run our update function on our database using that books DAO that we have exposed. So once we do that, we can finally add to the end of our toggle finished here. We can also toggle our databases finished as well. So I'm going to say view model scope dot launch, and then within here we're just going to toggle finished DB ID and then book dot finished. And now everything should be working how we expect it to. So if I let's check. Yeah, I'm going to turn my app online here. And then I'm going to run it again. And okay, so the two towers and then the Fellowship of the Ring, or the Return of the King rather. I'm going to mark those two as checked. Now, if I turn my internet off, so that I know it's going to be pulling from the cache in the next time, run my app again. You can see here, both of those are still checked. But if I turn my internet back on here, and then hit done, and run this again, you can see they're unchecked again. What's going on here is we have something called two sources of truth. Essentially, if we're online, we're going to pull from our online Firebase database, and if we're offline, we're going to pull from our Room database cache. So our behavior is going to potentially be different depending on where we are, because in our cache, we're updating the value on this finished field, whereas in our Firebase database, we're not updating that value. So this is going to be something that we fix in the next video. Additionally, you'll see something here. If maybe I mark the two towers and I click on that, you can see again, even within this app, it's changing back to the X for unfinished. So this is going to be something that we address and fix in the next video. But for now, we've definitely successfully created a database that we can use in our app for offline caching, which means that whenever we're offline and we want to run our app, we can do that. And this is definitely something good. Hopefully you learned quite a bit in this video. And to talk about single source of truth and see how we can fix this little bit strange and buggy behavior that we have right now, definitely tune into the next video and go ahead and click that like button and then subscribe to our channel, and you don't want to miss anything else that we'll have coming out.